Okay, so we're looking at what is called the integral function. Um, so we're going to let f be some continuous function on the interval ab. Okay, we're going to define g as the definite integral from some value c to the value x of f of x dx, where x is also on the interval ab. So what we're dealing with here is g is a function whose variable is x. X here is a variable. That's the problem. Okay, so this is a video on what we're going to call the integral function. F of x is some function on, it's continuous, on the interval ab, right? So we're going to define g of x as the integral from some value c to x of f of t dt. Okay, so note there's a lot going on here. C has to be some value on AB, and the domain of this thing is also AB. Okay, so note this is a function whose variable is x. That x is assigned here. In order to make this work, we've replaced the x here with a t so that it's a placeholder. Now, at this point, I don't need to do a whole lot of work. It's just pretty straightforward, and I can kind of get some values out of this without having to do any anti-differentiation, so long as I have a good graph of the function f, and I can calculate areas from that graph. So let's get a graph of that up. Okay, so this is my image of f, and we're going to work a little bit here. I'm going to define g of x as the integral from 2 to x of f of t dt. Alright, so how would I find, let's say, g of 3? Okay, so this is going to be the integral from 2 to 3 of f of t dt. Well, if I look, I have 2 here, I have 3 here, so we're talking about this area up here. Right, so we're talking about the area in this triangle. Alright, so that area is got a triangle, which is 1/2, its base is 1. The height of that triangle is also 1, which means that that g of 3 corresponds to 2 divided by 2 is, sorry, 1 divided by 2, that's not right. 1 divided by 2 is 1/2. Okay, so that g of 3 corresponds to 1/2. G eats 3 and returns 1/2. Alright, so what if I had g of 4, right? So this is the integral from 2 to 4 of f of t dt, right? So well, the first part of that integral, from 2 to 4, is still this triangle. It has a measure of 1/2. The second part of that is this triangle here, right? Well, that's a triangle that's below the line that also has a base of 1 and a height of 1. So this is like 1/2 minus 1/2. That means that's 0. So given that function g here, g of 4 would be 0. Alright, so let's get a little bit more room to work here. So let's clear out some space. Right, there we go. Alright, so what about, well, we're on a roll. We did g of 4. Let's do g of 5, right? So what would g of 5 be, right? Well, that's the integral from 2 to 5 of f of t dt. Well, I know from 2 to 4 is 0, right? And then I'm going to add another little triangle here that's below the line, so I'm going to subtract a half there. So that should be negative 1/2. So g of 5 is negative 1/2. If I took g of 6, right? Well, let's see, that's the integral from 2 to 6 of f of t dt. Well, from 2 to 5 is negative 1/2. And then, there's another little triangle up here with a base of 1 and a height of 1. That's going to add a half. So g of 6 has me back to 0. Okay, so that's kind of looking at things. Let's take a couple more and see what happens when we go maybe in the other direction. Alright, so let's clear out some more space here. Get rid of this work. And that little rectangle there, right? And let's see what g of 0 would be. Okay, so g of 0 is the integral from 2 to 0 of f of t dt. Well, the problem there is that's backwards. That's going from right to left. So we make this negative and change the bounds. So now I've got the negative 0 to 2 of f of t dt. Let's see, if I start at 0, right, and I go to 2, and there's the f of x there. So I'm talking about the region here. So that's a quarter circle, right? So this should be negative, quarter of a circle there with a radius 2. So this is pi times 2 squared divided by 4, right? So this just means I get negative pi as g of 0. So that area is pi, but because I'm going to the left and not to the right, it's going to come up as negative pi. Alright, so let's try one big one here and see if I can't get an idea of how to do this with a little bit larger scale picture here. So let's say I want g of negative 6. Okay, let's see, what do we got here? So that's the same as 2 to negative 6 of f of t dt, which comes out as negative 6 to 2 f of t dt, right? So coming from negative 6 all the way to 2. So this is the negative of, well, let's see. This is a triangle with a base of 1 and a height of 2. But it's underneath the line. So let's see, that's going to be base 1, height 2 divided by 2. That's going to be an area of negative 1. Oh, wait. That's not all the way across. That's to half, right? So let's actually think this through. If I go from negative 6 to negative 5, these two pieces are going to cancel each other out. So that's just 0 there, right? Now let's go from negative 5 to 3. Let's see, that's a rectangle. That has a width of 2 and a height of 1. So that's just 2. Here I have a triangle that has a base of 1 and a height of 1. Right, so that's going to be a half. Here I have a triangle with a base of 2 and a height of 2. Right? Sorry. That's 2 times 2 is 4. Divided by 2 is 2. And this here we just figured out was pi, right? So this means this should be negative 4 halves plus pi, or negative 4 halves minus pi. So if I take g of negative 6, I should get negative 4 halves minus pi. And there you have it. All right, so there's a basic understanding of the integral function and how it operates.